Pushes and Pulls by Anna Claybourne. This is Science in Action and How Things Work. Pushes and Pulls by Anna Claybourne. On the move. Things around us are constantly moving. Birds fly through the air. Plants sway in the wind. Cars zoom along roads. Rain falls from clouds in the sky. But what makes things move? Try this. Find a small ball or a marble and place it on a flat tabletop. In some sports, such as soccer, the ball moves around all the time. How many ways can you make a ball move? You can push it. You can flick it. You can blow on it through a straw. And you can make the marble change directions. What happened if you do nothing to the ball? Objects do not move on their own. They only start to move when something pushes or pulls them. These pushes and pulls are called forces. Pushing and pulling. Push and pull forces can make toy cars move. Try this experiment with a friend. You need a car for each person. Make sure that all the cars are about the same size. Then think about whose car is going to go fastest. You line up your cars somewhere with enough space, such as in the school hallway or in a corridor. At the count of 3, everyone must push their car as hard as they can. What happened if you stick 2 cars together and you push them as fast as you can forward? The second car gets pulled along with the first car. You can use tape in between the cars to attach them. Or, it's a fact, a toy car can move if it's pushed or pulled, but the harder you push or pull, the faster it goes. Now, some things can stretch and squeeze, like these modeling clay balls. Pushes and pulls can change things in other ways, too. Squeezing modeling clay is a type of a push. Stretching the modeling clay is a type of a pull. Squeezing and stretching changes the shape of the clay. Stopping. Pushes and pulls don't just make things move. They can make them change directions, slow down, speed up, and stop. What would happen if you pushed a toy car into another upturned toy car? Oh, the upturned toy car would make your car stop with the force that pushed back. Although the other car is not moving, it still has a pushing force because your car runs into it. Try this. Roll a marble along the floor, then try to stop it with different things, such as a book, a sheet of paper, or even your hand. Which things stop the marble moving? When the marble's way is blocked, you make a pushing force. If the force is strong enough, it pushes against the marble and stops it. The pushing force of the paper is weaker than the pushing force of the marble, so the marble is not stopped. What about the book, though? Dropping. If you hold an object at arm's length and then let go, what happens to it? Most objects fall to the ground if you drop them. If you jump up, you fall back down too. Objects fall because they're being pulled. This pulling force is called gravity. It pulls things down towards the center of our planet, called the Earth. When you jump into the air, gravity pulls you right back down. Gravity in space is not as strong as on Earth. This is why astronauts happen to float around. They also find it easier to make high jumps or leaps. It's a fact. We know how gravity works, but we don't know why it happens. Scientists are still trying to find it out. Earth gravity pulls things towards it. It pulls you down so that you don't float away. Getting faster. As an object falls or rolls downhill, it speeds up or goes faster and faster. This is because the gravity pulls it downwards. Try this for an experiment with gravity. You need 2 people, a small toy car, and a sheet of cardstock, sticky tape, and a few books. Fix the card against the stack of books using the sticky tape to make a steep sloping ramp. The card will bend. See the yellow card bend? To make a curved track for the car. Then hold the car at the top of the slope. Let it go and watch the gravity pull it to the bottom. Ask a friend to let go of the car. Use the hand to stop the car near the card. Now try stopping the car near the bottom of the slope. At the top, it is going slowly, so it hits your hand gently. But at the bottom, the car is going much faster, so it hits your hand harder. Ouch! You see this picture? Skiers pick up speed as they zoom downhill. Gravity pulls the skier downward. Slowing down. If you throw a ball or push a toy car, it doesn't keep going forever. Eventually, it will slow down and stop. Try pushing a coin across a smooth surface, like a table. It can move a little way after you push it, but it soon slows down and stops. If the coin does not slow down by itself, a force called friction makes it stop. This happens when the coin rubs against the table as it slides. Try to slide the coin on different kinds of surfaces. Try pushing the coin across a metal tray or a carpet that has more friction. Which one do you think it will slow down faster? I think the carpet. Rock climbing is easier in rubber-soled sneakers because friction gives them more grip. And it's a fact, smooth, shiny surfaces create less friction, so objects can slide around more easily. Rough or rubbery surfaces create more friction, so objects slow down sooner. Useful friction. Friction can be useful. It means the soles of your shoes and feet can grip the ground. Without friction, your feet would slide around and your hand would struggle to hold things. Try this. You will need a plastic bottle, water, cooking oil, and an adult to help you. Fill a plastic bottle with water. It's heavier, but you can still pick it up. Now rub oil on your hand. Now try picking that bottle up with one hand. What happens? It's a fact. The oil makes it hard to grip the bottle because the oil has less friction than your hand. When things rub against each other, friction produces heat. This can be useful on a cold day because rubbing your skin warms it up. Friction makes motorbike tires heat up and helps them grip the road surface. Friction warms your hands when you rub them together. Rub a cold coin on a smooth floor. The friction will warm your coin up. Pressure. I'm going to stop here. If you want to know more about pressure or machines or the glossary, the index, or the next steps, pretty cool information, go check out this book. Again, it's called Pushes and Pulls by Anna Claybourne.